Wow, this looks great. That's an awesome resolution. Okay, this will be fun. Whew. All right. This talk is called "Mikeal Drinks Water." Okay. Okay. Is that starting yet? Yes. Okay. There we go. All right. Here, I have to take this off. This is Slinky. All right. And I'm sorry if you listen to Radiolab, but basically, when you drop a Slinky, the bottom of it seems to like hover in midair. Okay. We're gonna see it again in a second, as soon as this is done bouncing. Keynote doesn't have a way to scroll through, or else I'd just do it. Okay, so this is like a giant-ass rainbow Slinky, and he's going to drop it at the top of this building, and this is going to hover in midair. And so for like a certain amount of time, the whole bottom of the Slinky is unaffected by gravity entirely, right? Like you can see it coming down now. This is fucking awesome. Okay, so what's happening here, and it's this crazy thing, it turns out that like all objects have knowledge, right? Like it's weird because we think of people having knowledge, but actually objects have knowledge. They have knowledge of all of the atoms around them and any kind of force that's applied to those atoms. And so the Slinky's relationship to itself, essentially, is like somewhat tenuous, right? It's not like a solid that's a rock. So when gravity gets applied to the top of it, what you're seeing as it comes down is actually the knowledge transfer of the force of gravity pushing it down. And the bottom's entirely unaware because it just like hasn't found out yet. What the fuck does this have to do with community? Okay, so this is these are some pictures from NodeConf, which is a conference I run for Node.js. It's like this, but we like laminate our lanyards. But anyway, so a community is built up of people, right? And in Node.js, like our community is all about making this platform better. And people obviously have knowledge, and we share it at conferences like this. But we don't have physics to govern the transfer of knowledge, right? We have language for person-to-person interaction. But for the really important stuff, for like the modules that we create, and all this value that we create that actually stacks up on top of Node, that fills out the rest of the platform, that is like the reason why it's so successful right now and the reason why you want to use it, we need to have a vocabulary and a language for knowledge and for information to transfer through those different components. This is sort of the key to Node's success, I think, is that we've found a way to transfer knowledge between artifacts and code and people incredibly efficiently, more efficiently than anybody else ever has. And so I'm going to give you a few examples and talk about some of the more important things. Oh, it cuts off his face. All right, that's half a Substack face. But you see the code here. This, I call this the Substack pattern. He didn't invent it, he just popularized it by writing like over 100 modules. But basically, module.exports equals function is not in the common JS spec. It's something that we added only to Node. And this is becoming like actually the predominant way that like popular modules expose themselves, is that the return value of a module is not like a grab bag of functions, it's actually a function itself. And so the default behavior of any module is just this single function that gets returned. And since this is JavaScript, right, for all the non-default behavior and all the extra little things that we want to add, we can just, tack those onto it. When you look at other module systems and other languages, most of them don't allow something this simple. And the predominant conventions are not, a single function or a module does a single thing. It's like, oh my god, in Java, it's like I'm gonna give you like all these classes and interfaces, and they have like 800 pages of documentation, and then you can like figure out how to plug them all together. And we have this thing where like you publish a module to NPM, and you write a README about it, and you get this little function, and it's really nice. Okay, we also have streams, and I'm not going to go really deep into streams because one of my examples is not on the slide deck, and also because Substack did a huge talk about it already. But streams are like this unified interface that we have in Node that is for any sort of file descriptor or anything that's just going to emit data for a long period of time. And the way that we handle actually manipulating that data and even handing it off eventually to another file descriptor is with another stream. So this is really important because like some of these modules, right, like request knows what like this request and response object is from core, but core doesn't know about request, and core doesn't care about request. It's like honey badger, don't give a shit. So yeah. But if you watch Substack's demo, which is far more impressive than these examples, right? He had like all those crazy streams, okay? So he didn't write all of those. Like, I wrote one of them. Dominic wrote like, I don't know, 12. And, you know, Substack wrote the other 40. And like, we're all writing these streams, but nobody goes into their stream and goes like, oh man, I need to handle the case where it gets piped to this other guy's stream and the case where it gets piped to this other guy's stream. Like, we had this unified interface, so as soon as we go and we publish a module and it uses streams, everybody can use it. This is like way different than platforms that build these like huge like vertical stacks, right? Like when you look at something like Dojo or like most Java stacks or really any stack that uses any sort of inheritance model, you get this plugin system where like everybody has to plug into different pieces, and like as soon as you create a layer, everybody has to build on top of that layer or you're below that layer or wherever. And there's not a lot of room for you to use value outside of that stack, right? Like you have to take the whole stack and then you have to like, if somebody else wrote some amazing module that didn't know about that stack, you've got to like figure out where it goes. We don't have that problem in Node. Like everybody who writes a stream, it just works as a stream everywhere. This, oh man, yeah, one of my examples is gone still. But so just the simple callback pattern, right? And like I know that people don't think that it works, but like it does. So error first, then success, okay? So error first and then whatever the result was. So the difference between like a callback and a stream is sort of obvious, but basically if you want to ask a single question and it's going to incur I/O, you use this simple callback interface. And because error is first, you like kind of have to deal with the error, which is rad. And because everybody uses this. Like if you publish a module that like returns promises or something, nobody's going to care. Nobody's ever going to use that module. It means that like if I write my little library and it goes and talks to Redis, and that's the last thing that it ever does is it talks to Redis, I can just like pass the guy's callback that passed it to me off to Redis. And when we do hit these problems like callback hell or whatever, like I'll tell you a secret. There's also like a coroutine hell and a monad hell and a hell for any fucking abstraction you ever create if you use it enough. The only difference is that for the 90% case, we have this super, super simple interface, right? So when you need to do one thing, you just get one little indent and then you're done. And when you have a complicated use case, you go and install async, like the other 827 modules that depend on an NPM, right? Like it's very simple to manage these callbacks once you decide to manage them. Okay, another thing that we really can't ignore and can't discount is how important GitHub has been to the Node community and to the project. So a lot of other platforms and languages are on GitHub, but they don't have the distinction of being a platform created after GitHub already existed, which means that at some point that community made a migration to GitHub, and some people didn't go. And at some level, they're not taking it for granted, right? I don't know if you did a lot of open source before GitHub, but it kind of sucked. Like, if I was like, oh, hey, here's this cool module that I want to contribute to, or like this cool project, I got to go find its wiki, and then I've got to go find the wiki page about code contribution, and then I got to figure out how to get a diff, and then I got to figure out like how to attach it to their Bugzilla or Jira thing that has like 20 form fields, and then I got to stick it in the right component, and God, I'm just going to throw up in my mouth a little bit. But it was awful. So GitHub is amazing because GitHub defines a language for contribution. When Charlie did his talk yesterday, he didn't explain what a pull request was, right? Everybody just knew it. GitHub is like defining the language of contribution for open source, period, for the, like this entire current generation of open source. Which means that the Node project has never had to have any of the conversations that people in Apache projects have. And the people like using projects that are like using their own crazy tool system or Google Code or whatever. These are just conversations that don't have to happen because we all share a language of contribution and we know how to contribute to each other's projects. We know how to log bugs. We know how to do everything. It's awesome and super, super great. Okay, so to prove sort of how, oh, that looks awful. To prove how amazing Node is and sort of what the breadth of Node is, I'm going to just give you a few examples. This is a temp pad, kind of. Tempvar was just up here. He was talking about the temp pad and how great it was. So he made like 3 of them and he gave me one. And it's so fun to play with. But when you get it, you like sort of go to his GitHub and you like look at this project and then you npm install like this temp pad library. So you have this little JavaScript library that gives you like events for all of the different pads, and it gives you like an API for setting the LEDs and all this stuff. So in like a couple hours, I wrote like a little Simon Says game where it plays a thing, and then I have to play it back. It's super fun. But I was at a coffee shop working with Max, because he's my co-founder, and hello, helicopter. In Oakland, we call them helicopters, H-E-L-L-A copters. They're not called, nobody calls them ghetto birds. Okay, so I handed this to Max when we were at this cafe. And Max was hitting it, and Max is a drummer, so clearly he wanted it to make drum noises. So in like 10 minutes, he plugged all of the events that were happening in the pad into Socket.io, sent them to like Chrome Canary, and then used the audio API to make drum noises. And like this sort of thing is crazy because, you know, like the people who wrote Socket.io and all these other libraries, like they had no idea that anybody was ever going to hook up something like this to it. And they didn't need to. And Max didn't need to learn anything new or really even look at the documentation for any of this stuff. He actually looked at the example from Temppad and just was like, I know how this works. So like being able to take all these things and plug them together and having all this stuff happening in like, you know, robotics and the Temppad and everything, and also all of this stuff in Socket.io, like people are sort of missing that we can plug them together way simpler than anybody's ever been able to. Okay. So this is, oh, that looks really bad. So that should be square. And it's the logo for a project called JohnnyFive. So if you've ever seen like the Short Circuit movie with JohnnyFive, that's JohnnyFive right there. Yeah. There we go. Everybody, like, you know, those kids in the 80s is all into it. Okay, so JohnnyFive was a robot, and this is a library for working with robots. It was started by a guy named Rick Waldron. So Rick Waldron's an interesting guy to be writing a robot library because he'd never, ever dealt with hardware before, ever. And he didn't even really know Node that well at the time. He'd played with it a little bit, but mainly Rick Waldron is like a primary like jQuery contributor. He's like on their like board and things and does all kinds of fanciness. So he started working on this library to make these little robots. And first he wanted to just make it move around, and then he wanted to like not hit things. And so every time that he was adding a sensor to it, because it was in Node and it was like just sort of easy for him to get at all these different I/O sources and abstract them and get streams out of them, he realized that he could just start plugging these streams into other Node libraries and doing other crazy stuff with them. And also, like those other Node libraries influenced his aesthetic. So if you look through the JohnnyFive library, which is huge, by the way, it has like, you know, tons of different servos and connectors and all kinds of different APIs. They're all like this beautiful jQuery sort of aesthetic for an API, but they also will return streams when necessary or R streams when necessary and use simple event emitters and callbacks when applicable. So really, like all of these new hardware bits that he's getting can like be used with the rest of Node. And so this is a little interesting. You can't really see it. I'm sorry. So Rebecca Murphy works with Rick Waldron, and she was like, I want to play with hardware too. Never played with hardware, not really that familiar with Node. She goes out and buys a little LCD and wants to start programming it with this library. And so as soon as she gets like serial port plugged in, she's like, oh, okay, all right, now I need to write an API into JohnnyFive for this. So in like a couple days, she learns how to do bit shifting and writes like this beautiful API for manipulating the LCD. Like honestly, I've tried to look through and find other APIs in other languages and even what the C stuff looks like for what it looks like to manipulate an LCD like this in another language, and nobody's written anything this easy before. Like they're dramatically lowering the barrier to entry for people working with hardware. And this is, I think, more impressive than any other abstraction that we've done in Node, because other people have done a pretty good job of abstracting a lot of the things that we now abstract in Node, right? Like Express is like just a tiny bit better than Rails, like not that much. But no, like nobody's ever really written a good API for doing this kind of stuff. Like people who hack on hardware are not the kind of people that work on jQuery. Like they've never really met before, and so like beautiful API aesthetics have never made it this far. So okay. Switch gears like a tiny bit. So like how did we get here? There's this just looks terrible. Okay. There's this Okay. So there's this graphic novel called Logic Comics. If you haven't read it, you should go read it. It's awesome. Yeah, Dominic knows what I'm talking about. So it's about the early logisticians, and it mainly follows Bertrand Russell. And what I found really interesting about this is that the entire field of logic, for an incredibly long time, they were writing proofs about sort of like higher level logic stuff. But the main focus of the entire field was on proving basic arithmetic. They were basically like, they were building their proofs on arithmetic, but there was no proof for arithmetic. Nobody had ever written it. It was just like too complicated. And they all sort of assumed that it would exist, but it was like this holy grail to prove basic arithmetic. And some people got kind of like philosophical with it, like when we prove basic arithmetic, we'll know the foundations of the universe are true by like our understanding of them. And some people went as far as to be like, religion will just go away. Like, we just won't even have religion anymore because we'll have a proof for basic arithmetic. Little crazy. And in fact, many logicians went insane trying to do this. But that was the focus of the entire field for a long time, and they didn't do a lot or make a lot of progress above that and above basic arithmetic. And it sort of took over the field for quite a while. So then this guy, who's all lips, so then enter Rocky Horror Picture Show. So this guy, this is Gödel. So Gödel, there's this big conference, right? It's like JSConf for fucking logic people, and Gödel, and JSConf EU because it was definitely in Europe. So Gödel says like, oh my god, I did it! I have a proof for basic arithmetic, and so everyone shows up. Like, it was definitely like JSConf. And so everybody is in the audience. Bertrand Russell's in the audience. Like, everybody who's ever done anything in the field of logic of Node is in the audience. And Gödel's kind of a troll. Like, he sort of bait and switched everybody because what he actually proved, in fact, is that it is impossible to prove basic arithmetic. And he had a very compelling and very true proof that essentially a few things sort of multiply by infinity, and therefore you can never prove basic arithmetic, and everybody should give up. And so most of the people left incredibly depressed, because they wasted most of their lives. And a few people actually ignored him and just kept trying to do it, because they're crazy. But one guy actually found it somewhat inspiring and enabling, and that was Alan Turing. So Alan Turing was in the audience and was like, oh great, I can stop fucking around with basic arithmetic and just make assumptions, right? And so the field of logic at that time started to make assumptions, started to take a few things for granted. And slowly they built on that until Turing eventually did like the first computers. And computers have always been logic machines, but the trick to computers is that we make a lot of assumptions about things just working. And we've sort of like, once something works enough and we can assume that it works, we just like forget about it. Like, that's a solved problem, and now we build on top of it. And so like, what does this have to do with what I'm talking about? So I truly believe that the last like 10 or 15 years, we've stalled out a lot in computing, and we have not worked our way up the stack very much at all. We haven't solved a lot of really great problems for programmers above the language level and above the platform level, because everybody's obsessed with writing a language or writing a better platform. And we aren't taking things for granted yet. And one of the amazing things about Node is that our intention is to be done someday. Our intention is like, after 1.0, to not really do any more API changes and to make this a solved problem. And we already believe that the language is done, right? So we have, okay, ECMA was at the top. So I'm talking about ECMA too, you guys. We have these like standards bodies, right? And Node has made a very, very conscious effort to ignore them and to have pretty much nothing to do with them, because they're mainly roadblocks. And the biggest problem with these institutions really is that they were created to solve a problem that is essentially solved. But institutions don't just go away, right? They persist. And most of their process hangs in trying to solve the same problem that they were created to solve, even if it's already done. And so like the key to Node's success really has been like not caring about what these guys do. Like, fuck these guys. Really, like, who cares? So another little story. That's Lenin and Trotsky. So Lenin and Trotsky, if you don't know, they like did this whole Russian Revolution thing. And so they'd go in with their army and like they'd kick out all the Tsarist government. And then they'd be like, hey, we kicked out the Tsars. And everybody's like, yay, those guys were dicks. And then they're like, okay, all right, so this is Oleg, and Oleg's going to take all your money. And then Oleg's going to give you enough money to live, and then he's like probably going to steal the rest. And like if you have a problem with that, like talk to Oleg. So that kind of sucked. And like when you talk to standards bodies, they constantly scream at you. They're like, no, you can't get rid of us. If you get rid of us, like you'll be running Windows, and Apple's going to take 30% of the money from your website, and like all these big corporations are going to take over, and it's going to be awful. There's no alternative, okay? So this guy, Nestor Makhno, he's fucking awesome. Okay, so at the exact same time, literally the exact same time that they're going through and kicking out the czars in Russia, he's doing the same thing in the Ukraine. The difference is that Nestor Makhno would come with his army and kick like all the czars out, and he'd go like, "Hey, I kicked out all the czars," and they're like, "Yeah, those guys suck." And he's like, then he'd take a big black flag because he's an anarchist, and he'd plant it, and he'd say, "You guys are all free now. Do whatever you want. Organize yourselves. I'm out. Peace." And they did. They just sort of organized themselves and made everything work and were incredibly happy. And his army actually grew like exponentially because most able-bodied men were like, "This guy's a badass. I'm gonna fucking leave and follow him around." And it was really, really awesome, okay? And so this is what I actually think would happen if we kicked out these standards bodies. If we actually started kicking out these institutions, and we just went, "Hey, let's do a bunch of stuff," we'd get a lot more done and everything would be great. Great example. Who here has heard of source maps? Show of hands, okay? So source maps are going to solve like a shitload of problems, okay? Like mainly source maps are going to solve the fact that like when you deploy JavaScript code and then you have to debug it, you can't. And then they're going to make that basically as easy, right? Source maps are amazing. Source maps are a spec that is in a Google Doc that is shared writable by a couple engineers at Google and a couple engineers at Mozilla. And they talk to each other, and they edit it, and they implement it, and they don't even really have a mailing list, and anybody can view it, and the shit works. And it's awesome. And this never would have happened to the W3C. The reason why they're out there on this Google Doc is because this kind of work is just impossible to get through a standards body, especially at the kind of at the speed that they want to do it. So yeah, that's all that. All right, there's also a RabbitMQ in there. So this is a little bit harder to explain, and I almost cut this slide because it's something really new that we're just now coming around to. But there's this idea that we've had for a long time, and it's sort of ingrained in our brains when we think about writing big applications, is that when an application process or application code gets to a certain level of complexity, we sort of go, "Oh, well, let's put some infrastructure behind that," right? So we break it off, essentially, and we say, this task belongs to, something in Erlang that people have been working on for 10 years, or some C thing that people have been working on forever. It's RabbitMQ or something like that. Or we actually just take that code out of that application process and then manage another cluster of processes, right? And this idea of infrastructure and this sort of, this tool that we grasp at that's another thing that we need to run to solve a problem, it comes from when all of our platforms sucked at concurrency. And when we really couldn't horizontally scale any of that stuff above a certain level. And so what a few people are finding, like me and most definitely Substack, I credit him with this more than anything, is that infrastructure has a huge weight to it, right? It's a big black box that you've got to keep up and running, that you have to figure out how to debug, that has a different logging structure. It has a huge cost associated with it. And if you can remove it, and if your node processes can actually continue to scale horizontally, and you can keep building them out that way, there's no reason to break things up. It's actually not beneficial. And all of the papers that people write and all the blog posts about this is what a clean infrastructure looks like and blah, 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 they're justifying the old infrastructure after the fact. They built that because they couldn't do it the way that they wanted to. And now, now it's gospel. So that's the last sacred cow I'm going to burn. Oh yeah, that's great. So this was the NPM website. I'm closing in on the end here. In case anybody didn't believe me that Node is dominating. So today, there are over 15,000 packages in the NPM repository. There were about 8,500 package downloads yesterday, about 2.5 million in the last week. 85,000? Okay. Yeah, or sorry. Oh, 8,500? Yeah, sorry, 85,000. Yeah, that math wouldn't have worked out. And in the last month, there's been about 108 million package downloads. No, it's 108. Oh, okay, 10 million. Yeah. That's true. Hey, patch is welcome. It says right there, patch is welcome. All right. So let's do a quick comparison. RubyForge has 9,000 packages in it. So we're already more than that. RubyGems.org, which is like the community version of RubyForge, has less than 3,000 packages in it. Python has 24,000 packages in it, but it's been around since 1989. So we've been around 3 years. We'll close in on them by the end of next year, because we've doubled in the last year, by the way. And the amazing thing about all these packages is that the vast majority of them actually work together without a lot of glue, without a lot of problems. Like, we're accelerating faster than any platform I've ever seen. And the amazing thing about this acceleration is that it's not linear, right? It's not that we're like just getting better at like beating Rails, right? Like, we're fucking doing robots. Like, that's amazing. Like, you saw it, right? Fucking robots. You ever tried to write a robot in Python? It's awful. I know I tried. And I mean, that's about it. I'll leave you with this, and I'm going to drop the mic.